Hello and welcome to the InfoQ Podcast. My name is Wes Reisz, co-host of the InfoQ Podcast, chair of QCon San Francisco, and VP of Technology for Section. Today on the podcast, we're talking with founder and CEO of Solo Idit Levine. The mission of Solo.io is to simplify the journey to cloud-native infrastructure. Towards that end, we're going to be talking today with Idit about what she talks about as Solo's three pillars. These are an API gateway built on top of Envoy, so we're going to be talking a bit about extending Envoy. We're going to be talking about managing the service mesh. So in this part, we'll talk a bit about SMI or service mesh interface and some of the work that Solo and Idit's been doing in that space. And then finally, we're going to talk about extending the mesh. Here we'll talk about Solo's recent announcement of WebAssembly Hub, among other things. Thank you again for joining us on the InfoQ Podcast. We're now in our third year. Can you believe that? And we're more excited than ever to continue bringing this podcast to you. So thank you so much for continuing with us on this journey. Idit, welcome to the InfoQ Podcast.
Hey, thanks so much. Really excited to be here.
So before we jump in, tell me a bit about Solo and the work you all do. Level set us. What are the problems you all are trying to solve?
Awesome. So I started Solo 2 years ago. And what I was trying to do is helping customers to transform and be more innovative. When we started it, I basically was very, very passionate about service mesh. But 2 years ago, I realized that will take a while until it's actually going to get there. So I tried to figure out how I can help them right now. And the first thing that I noticed is that most likely, if they move to microservices, right now they will have way more API. And to manage that, it will be way simpler if they will have a very good, innovative API gateway. So that's the first problem that we try to solve. We open source Gloo, I want to say a year and a half ago. And Gloo is basically an API gateway built on top of Envoy. Why Envoy? Because Envoy is the stepping stone for service mesh, right? Most of the data plan in service mesh today are using Envoy. So when we started Gloo, 2 years ago, I realized that will be something that the direction of the market is going to go. So it would be a very good to start with that and basically have people running in production Envoy already, get used to it, but in a simple way than sidecar, but basically on the API gateway level. Gloo has, like his name, his idea was to help with the transformation because we realized that in a given time, until you actually move all to microservices, or maybe you even cannot move all to microservices, you most likely run different type of workload on your infrastructure. So that could be something like monolithic, microservices, and maybe even serverless. So the idea with Gloo was to kind of like gluing the environment and make sure that you will be able to manage them all with one API control plane. So it's built on top of Envoy. It's very, very flexible on the point that it's very pluggable. So that's where we started. But we always wanted to go to the direction of service mesh. And when I looked at this, I realized that there is not a lot of point for me to actually try to compete with any of the big player out there, like Google or running STO or, Buoyant, who was really, really, Linker the leadership, or even HashiCorp, because we help build Console Connect. So when I looked at this market, I said, I definitely don't want to put my resources to compete with it. But what I think that I can do is realize what will be the next problem when everybody will adopt service mesh. Now, I do believe that everybody should adopt service mesh because when you move into microservices, simple question like how do you making sure that two microservices will communicate to each other? Make sure that they will do it in a secure way. And you see what's going on in your cluster is something that you will have problem with. It will be more complex, and therefore service mesh will solve those problems for you. So again, I didn't want to build a service mesh, but I realized that by that time when we actually help Ashi build console, I realized that there's going to be more than one service mesh. Maybe it's not going to be different type of service mesh. Maybe it will be more instances. So maybe you have two STO instance, but you will need two instances because maybe you have two clusters. And the question that's coming up is that how do you manage them? Right? So this is a big question. And this is something that when we built Console Connect like a year ago, that's where I started thinking of it. And I realized that specifically, if you actually adopt one of those meshes on-prem, and then you want to go, for instance, to AWS, you most likely will want to use App Mesh. And it's a good question, how do you actually orchestrate it, making sure that they're kind of like group them to treat them as one mesh. So that's basically the second thing that we did. We're calling Service Mesh Hub. And Service Mesh Hub is basically managing no matter which type of service meshes, but it's also grouping them together. So it can install, discover, and do a lot of stuff. So that's the second thing that we do. And the third thing that we realized back then is that there's nothing in Service Mesh that, like the Service Mesh today, when you're talking about it, people are talking about the use case of it. Oh, you can do MTLS. Oh, you can do observability. Oh, you can run. That's all great, but this is a use case. This is not the way it's actually implemented. And I think that what's special about Service Mesh is the way it's implemented. And it's implemented in the way that it's abstract the network. And if it's abstract the network, in my opinion, there's way more stuff we can do. And this is where we're basically focusing in Solo, is basically extending the mesh. What can we do in order to make the mesh use a different use case? Like who said that in iPhone you can only talk, right? You can do way more, and you're extending it with app. So that's exactly the same idea. To me, Service Mesh is a platform that we can extend.
So I've got App Gateway, Service Mesh, and then extending the mesh. Let's start off with App Gateway. So you built on top of Envoy. Why Envoy?
So I looked at it like 2.5 years ago. I mean, there was probably a few reasons. The first one is because you can extend it. Like Envoy is coming out of the box with the ability to write filter. And we knew that it's hard. It's not simple to write filter, but I know that we are very capable. So I thought that the fact that I can actually extend Envoy functionality by writing filter in C++ acting will be a differentiator in this market. So we can take something like Envoy and basically make it ability to directly route to an AWS Lambda and create the signature and everything and kind of directly spin up a Lambda. Or we can do a lot of stuff related to transformation and caching. And we saw that because we are pretty efficient of how to extend Envoy, that will give us a huge advantage. This is not, it's working in different proxies like Nginx and H3 proxy. Basically, you can use the API, but you can't actually live inside. You can be compiled to it. So we really thought that that's a huge advantage. The second one is the fact that it's driven by an API. So it's not a file that you need to auto-restart the proxy. I really like that. I felt that this is a very cool architecture. By this time, I already knew that Google choose a Envoy format for STO, so I will assume that they will join the community, and I will assume that they're going to be a big community, so that's another advantage that I felt that we have. Of course, performance, right? I mean, in the nutshell, that's all we care. I mean, proxy that you're reading in Go or any other language, the performance just cannot compete with something like Envoy, who's reading in C++. I think that that's the right way to go. So that was a big major.
When we talk about API gateways, we talk about that ingress into the cluster. Some of the things I think about, like SSL termination, I think about maybe some traffic routing, but what are some of the features that Gloo or an API gateway really give you strength at?
So I will argue that most of our customers and the people who actually want to use us is usually choosing us because two of reasons. One of them is security. So a lot of security stuff. So we have customers that ask for LDAP, API key generation. We have policy. We're supporting an open policy agent. We have filters that we wrote that we are the only API gateway that has that based on Envoy, which is WAF, Web Application Firewall, data loss prevention. So we have a lot of finance organization users, and therefore we had to make security first for citizen. So we have stuff like rate limiting and a unique one, more advanced one, mainly because we have customer like Vonage, who is an API company in a way. And they need that crazy rate limiting capability. Basically anything else, right? So like basic code, DEX, integration, OpenID Connect, of course, JOT, API keys generation, custom auth, TLS, MTLS, Let's Encrypt. You have policy like CORS and Open Policy Agent, RBAC, Kicklog. Delegation, that's really, really important. We have the delegation option. So I'm owning Solo IO domain, but maybe I want to give you the ability to own Solo Press, right? Solo IO/press. So I will give you to be the owner, and you will be able to do whatever you want with it, and you can continue delegate that. Yeah, and then as I said, the WAF, DLTP, rate limiting, circus breaking, so everything that basically related to security that's going a long way with our customer.
And these are all implemented on top of Envoy as like filters that are actually written into the proxy?
So some of them are. So like WAF and all of this is a C++ async filter that we wrote. But some of them like external, like OPA, for instance, this is going to the external host, so server. Basically, you can imagine that you can actually have a request and OPA will approve you, but also will say what you're capable of seeing when the request is coming from the endpoint. So imagine just for of it, we have a big company that related to dental. So assuming that we want to be able to look for the doctors, but we don't want to see their license, let's say, right? So basically, they don't need to modify the backend. What we're doing is that on the request, it's going to Autopilot say, yes, but this customer can only see those fields. On the request, we are filtering the license and bring it back to the user, right? So basically a lot of policy of what you can see and so on. And again, all the idea is just to make it very simple for you, not to need to remodify the backend and so on.
Yeah, totally. So the two other things you said was the service mesh hub and extending the mesh. Before we jump into those, I wanted to ask you about licensing model. So this is all open source, right?
So everything is open source in Gloo. Besides, there is some stuff like security that we are all on the license of the enterprise. And you can potentially bring your own. So like you can totally do this in the open source. We have a lot of users that are user open source. And then they just bring in their own rate limiting server or their own external out server. So that's basically the only thing. We also have a UI. It's not open source. It's free. But most of the stuff is in open source. As I said, minus some little stuff in the security that it's part of the enterprise. And of course, support, right? Support is part of the enterprise.
Yeah, same code base though between open source and enterprise?
Definitely. So one thing that Gloo is really, really big on is the pluggability. So when I understood that we're building on top of Envoy, I also assumed that there's going to be a huge work from the community on Envoy. So the way we build Gloo is written in Go. From the get-go, it's always it was always Go from the beginning. And the Gloo is working is very pluggable. The architecture is very unique. It's basically watching CRDs. And every time that something changes in your environment, in your configuration, or in your security, like for instance, you had certificate rotation or something like that, Gloo immediately is detecting it and then basically sending it to a plugin system. And the plugin system, each plugin knows to basically translate it to an Envoy system, an Envoy snapshot, and basically then we're aggregating all the information back and we're serving the snapshot to Envoy. So that means that we can go very fast. And if you ask me why we are winning a lot of the accounts that we're going with, it's mainly because of it, because our customer are really, really amazed at how quick we can actually give them a custom use case. Like, for instance, they want an HMAC or they want something specifically to them. Again, for us, it's mainly mean that either we need to write some plugin in Go, or most likely we need to write some plugin in Go, and maybe we should write filter. Maybe it's just something that we're consuming from the community itself. So we can go very, very fast and bringing to our customer a tailor-made solution. And I think this is the key things in Gloo, because we just want to make it so easy for them to adopt.
Very cool. Okay. So the second thing that you talked about was the idea of service mesh, kind of a service mesh hub where you could interoperate between multiple service meshes. So tell me more about that.
Sure. So I will explain where it started from. So as I said, back on the day, Mitchell and Armand, they were good friends. They reached out to me. They said that they were interested of us helping them. They build these things called Console Connect. They're going to announce it. And they need support for Envoy. They knew that we know Envoy. So we basically asked us to do the integration for Console Connect to Envoy. When we started working on this, I basically realized that STO back in the day was pretty mess. And Linkerd was just migrating from Java to be Rust Go implementation. And I realized that, there's nothing really good out there, like really, really good. And therefore, usually when you have an ecosystem that there's no real dominated player, usually what's happening there is competition. And I assume that we've been there already, right? With the orchestration of service of a container orchestration like, Docker Swarm and Kubernetes and Cloud Foundry. And Mesos, we knew that happened before. And it took a long time until Kubernetes became the winner. And, in my opinion, in the service mesh ecosystem, it will look a little bit different. I don't think they're going to be a clear winner, and I will explain why. So when I thought about it a year and a half ago, I realized that there are going to be more meshes. And when I talked to customer about service mesh back then, what I realized is that people doesn't know which one to choose. So they try. They're starting with STO and they see it's very complex. Then they're moving to Linkerd and they're saying, yeah, that's easier, but it's not an Envoy base. So I don't know if it will be the winner. Then they will go to something like Console Connect and will discover that actually Console Connect didn't even have layer 7 support. So, basic stuff is not going to work. So they're basically wasting a lot of time of learning a lot of new API and a lot of stuff, but in the nutshell, they're just wasting their time. There's nothing that they're putting in production on that time. So first of all, we wanted to help them. And the way to help them is instead of them learning a lot of the API, what if we will come with this API? First of all, we will make it that simple, not as complex as STO. And we're just going to basically make all those meshes speak the same language. If everybody's speaking the same language, then it doesn't matter. You don't need to learn a full set of new API. You just going to try and see what is good and what is not.
This is where SMI came in, right?
Exactly. So I announced it, I think November, right? This is when actually over a year ago, November 21st is where we opened SuperGlue, which basically out of the box was trying to target this problem. Now, I think there is another problem that solved, and this is very important, is that locking to provider. Because if you think about it, I mean, think about customer that chose Mesos 2 years ago. They seriously took all the money that they invest, and that's a lot of money and a lot of education and teaching the team, and basically throw it to the garbage. They needed to start from scratch. And that's a big problem, right? I mean, that's not something that a customer will prefer to do. So I think that by coming with this API, it doesn't really matter what you're using below. Like, even if you're starting with Linkerd right now because it's the best, if STO will become the best, just switch, right? I mean, it's not going to change anything from your configuration or from your workflow or nothing for the user. So I think that was a powerful one.
So I mentioned SMI, Service Mesh Interface. Can you talk a bit about specifically it?
Yes. Basically what happened is that we announced SuperGlue on November, and later, probably 6 months later, Microsoft reached out to us. And they basically said, look, we really like this thing. We really like SuperGlue. It sounds very interesting, but we wanted to kind of like help you push it because you're a startup. We think it will be very, very useful. We will do that all together. What we can bring Microsoft as a big company is the marketing and to make everybody agree. Because, I can go as much as I want to, to Google the other and try to ask them to agree. But, I'm a small player, it's really hard for me to actually.
Yeah, it helps when Brenda and Greg talks about it, right?
Exactly. So they basically what they offer, and we thought that it's great. They went and talked to Ashi and to Buoyant, and we all agree. And basically it's based on my vision and our work. And we announced SMI, Service Mesh Interface. And the idea with Service Mesh Interface is exactly that. It's the abstraction on top of Service Mesh that basically will allow you to use one language to configure them all.
Okay, so let me ask you a question on that, though. So when you have one language to configure them all, and you're talking about console, and you're talking about Istio, and you're talking about all these different service meshes, does that mean that you're trying to make them all happy so you can only do a very small subset of operations? What does that mean?
So this is what the SMI is doing. Actually, what we're doing with Service Mesh Hub, and we're actually doing more than that. What we're doing, we're basically trying to actually go on the high level of making support to everything. And the worst case, we're basically throwing an unimplemented. So we basically do want the customers that if he has something in those service mesh, you will be able to do this. So there is two ways that we're doing it. First of all, is that by creating a way wider set of APIs. So we're calling it SMI++, right? So basically that's what we're doing in there. And the second thing is you can also potentially go and configure your STO, and we will be able to basically take what you put in SMI and attach it to what you went directly to STO and bring it to STO itself to be configured. So that way, if you have a very specific, strange thing that no one thought about it, and therefore we didn't put it as an SMI, you can still achieve that.
Is that open source?
So it will. One more thing that it's not only SMI, it's important to say that, is that on the beginning when we started with SuperGlue, I also understood that there's going to be another problem. And this problem is the fact that not only that you will want to maybe talk to a different service mesh, you maybe actually will want also to treat them as one. So for instance, just if looking today at the cloud, right? You have STO in Google Cloud, right? They will use STO. AppMesh in AWS, and Microsoft is working on something as well, right? So we will have 3 different implementations of service mesh in 3 different clouds. So you know what I mean? That's why I'm saying I don't think that they're going to be like the Kubernetes phase that everybody eventually agree on Kubernetes. I think that they're going to be always more than one mesh. So now the thing is this: if you're running on-prem and you actually want to, to use, I totally see how when you go into AWS, you should use AppMesh. First of all, it's for free. Second of all, it will be work integrally like crazy with everything that they have, like EC2 and everything together. And therefore, most likely you will want to use it. So I wanted to solve this problem. And again, I thought about it when we built Console Connect. What will happen if you want to use, let's say, Console Connect on-prem or even SD on-prem, but you still have also a cluster on AWS? So what we did basically, we allowing you to group meshes together and said, this is my production mesh. I'm going to have one mesh of STO on-prem and one app mesh in AWS. And we will group them as one, and because they're all using Envoy, but even if not, we can actually flatten networking. So if we're actually making sure that you flatten the networking, now every service from this mesh can securely and fast talk directly to a service on the other mesh. So once you actually grouping them together, we actually treat them as one big mesh. To the user, he doesn't care. He doesn't even know. They're talking all the same language, which is SMI, right? But what you can do basically is group them and say, this is my production cluster. Therefore, I want the same root certificate. I want the same Prometheus, let's say, right? I want it to aggregate eventually to the same Prometheus because I want to see what's going on there. I want to be able to route safely and so on. I want MTLS for both of them, for instance. So that's basically what we did. And I think this is a key differentiator. And I think this is very, very interesting. So discovery of everything and yeah.
And so you have multi-cloud, multi-service mesh environment that things like even service discovery is all treated like it's the same registry?
Exactly. Everything is one control plane. You can see everything. You'll be even discovering your cluster and then discovering the mesh inside and then discovering the configuration of the mesh. And as I said, if you want, you can also install from us, but I will argue that probably most of the people will just going to want to discover. And then, yeah, you can just group them. And once you group them, everything that's happening, like you install one STO, will happen with those two together. And now you can come and give them like as a group of meshes, configuration and treat them as one. For my opinion, this is very, very powerful because that's giving you the ability to basically, abstract all the mess, right? You don't need to know anything about that. You just need to do what you can do. And the visibility and that we're making sure health, we're making sure upgrade, we're making sure everything. So we're basically kind of like helping you do all this stuff. So you will be able to see troubleshooting. We're bringing you all the configuration and everything and the logs from every meshes that behind the scenes. So you will be able to come and be able to look what's going on.
What about something like identity? How do you manage and maintain identity across service meshes that may all kind of implement it differently?
So the only thing that is trouble, and we work in it in our way, is identity. So like, if you're looking at a service mesh, not everybody's doing identity of the same matter. I wish there was. Theoretically, they should, right? But for instance, LinkedIn is not supporting SPIFFE right now. So the question is, how do you manage that? And that's very also sensitive because it's all about security. But we overcome that. And actually, we have a very nice solution that allowing to do this. So, everything that should be on the level of the grouping is something that we are managing. And everything that else the mesh is doing. So we're basically doing the piping of how something like that is going to look when one service want to talk to another service in the other mesh.
The last thing you mentioned that Solo focuses on is extending the mesh. I think this ties into a recent announcement you all made about WebAssembly Hub. So what does it mean to say that you're extending the mesh? What's it all about? And then what is WebAssembly Hub?
So there is two parts on the mesh. There is a control plane and a data plane. So the data plane, most of the time is Envoy, but it could be the RAS proxy that the Linkerd guys wrote, or it could be the traffic one that the mesh has, or, it could be Nginx, it could be everything. But most likely it will be Envoy. So that's one thing that you will need to be able to extend. And that's basically the sidecar that everybody's talking about, right? It will be everywhere. And you need to be able to extend that. The other thing that you need to extend is the control plane. And the control plane is basically what giving the configuration to those proxies, right? Because in the nutshells, eventually when the request is coming, it's not going through Gloo or STO, any of those. It's going directly to the proxies. But what the control plane responsibility is to basically teach Envoy what to do when a request coming to it. Oh, a request coming and it's whatever, with this prefix, go to this route. Oh, it's coming from this user, you're not allowed to go there, right? So that's basically the idea. So that means the control plane. So let's think right now, what is the way to actually extend a control plane? So control plane is actually can be extended with operators. And operators is not new. It's not something that we invented. Actually, operator is something that they're coming from people like Reddit and others, and they CoreOS guy push it a lot. And that's the idea of actually how to create something that will be able to operate your clusters. Usually, it's coming in a concept of Kubernetes. As you do writing operator to Kubernetes. So Kubernetes, it's great, but service mesh is not Kubernetes. And it needs to watch different things. We care about different things. And specifically, if you think about service mesh, think about what we just did. We took basically the network from the users and abstracted and own it. That's it's a lot of power, right? If you have all the network for yourself, there is a lot of crazy stuff you can do. But think about it. It's also, with great power comes great responsibility. So now the question is that how do we make sure that we are not messing it up, right? Because if we mess up, you just lost out to your network. And the way to do this is actually create a mesh that is resilient, right? How do you make a mesh that is resilient? So we're trying to do a lot of stuff, right? I mean, service mesh app, that's what we're trying to do, right? We're putting some guardrail. We're making sure the validation that everything is okay. We're making SMI to make the language of the mesh easier. We're doing GitOps pattern to make it better. But in the nutshell, if you think about it, what's special about all the stuff that we're doing is that it's still driven by the user. And I think that when the user actually will want to change mesh, it will want to change mesh if there is some change in his environment. I spin up another service, I want to route to it. I looked at the metrics, it seems that my version is not doing well, I want to roll back. So that means that you need to look at your environment, and usually that's done by the user. So what we were thinking is that basically what we need to make the mesh is adaptive. And how do we make an adaptive mesh? By using operator. So we build a specific operator framework for service mesh, because that means that it should watch stuff that's relevant specifically to the mesh. Something like telemetries of the mesh, traffic, and so on. Stuff that the mesh really care about, as well as, of course, CRDs, and we make it multi-cluster and so on. So, and then basically, the result of what's going on is basically will be to change the mesh configuration. And the only thing that the user actually need to give us is the rule when to do this, right? Oh, I just saw that the metrics like this, so whatever, execute that. So we actually build an operator framework that we're calling it Autopilot that is specifically for service mesh. If you want to build a service mesh operator, you probably should use this. It's free, it's open source, and we open source it on KubeCon. So that's basically how you're extending the control plane. But the question then is bringing us, how do we extend the data plane, right? And that's important because that's something that the user eats when actually a request comes. So, before the days, people were doing it with Lua. Lua is, first of all, is not something that maintain anymore. It's end of life for it. And also it means that you need to write those extensions in Lua language, which is, I don't know, you need to learn that, right? What Google guys, together with all the community of Envoy, basically decided is that probably it would be way better to bet on WebAssembly. In the nutshell, it's exactly the same idea with Lua, right? It's a sandbox environment that basically you can actually extend Envoy without the need to actually recompile it, which again, it's not simple. So when we thought about it, why WebAssembly is better is first of all, because you can write with any language you want. It's sandbox, which means that if you potentially, it's not going to take on Envoy down. And, the performance will be really good and so on. So that's kind of like the way the community decided to go, which is WebAssembly for Envoy. But, WebAssembly, like everything, it's still complex. You still need to build it. And you still need to publish it somewhere. And then your proxy need to take it from somewhere. And all that process is actually something that is really, really daunting right now. And the community didn't realize that yet. It's really, really early. So that's the second thing that we did. We announced last week something called WebAssembly app. And the idea with this is basically, my vision is that eventually it's exactly like Docker-like experience, right? I mean, Docker container was there before Docker make it easy to use. But the way they make it easy to use, this is what makes the huge mass adoption. So we try to do the same thing for WebAssembly. So the first thing that's complex about that is that you need to build it. So, you need to build it, then you need to compile it for WebAssembly. That's already not a simple thing. So we created something called WASMI, which is basically a command line that it's very simple. Seriously, it's like Docker, right? WASMI init. It's setting the environment with the right container that you don't need to download anything. It's already download Bazel and everything that you need inside and setting up the environment ready for you to actually build it. Then it's giving you a clone of an example WebAssembly. You are changing whatever you want, and then you're doing WASMI build. It's building the WebAssembly for you. Pretty simple. Then you need to store it somewhere, right? And you need somehow to bring it to Envoy. And for that, what Docker did was a hub, right? There is a registry. You need to push it to a registry. So WASMI push basically will take this WebAssembly that you build and push it to the registry that we created. So that's the next one. Now you can pull it back if you want to run it locally. But more important, you can actually deploy it, right? Because in the nutshell, what I want is to deploy it. So today we're supporting 3 ways to deploy it. And this is only the reason because that's the only 3 ways that exist today in the market that actually support WebAssembly. So this is, if you want to do it with basic Envoy, right? So a deploy function, minus, Envoy will do all the work for you. Same thing with Gloo. Gloo is our API gateway. It's already support out of the box Envoy. with WebAssembly. So that means that it will be very simple for you just to say deploy. We're already going, we're updating all your configuration, and Gloo know how to go to the registry, take it from there and give it to Envoy. And then the last one is STO. And that's kind of like the nutshell of the same thing. I mean, we added this functionality to STO to basically go and be able to modify STO that way that you will be able to go and STO will be able to grab the configuration for the registry. And the last one that we did, we thought that a lot of the people in the community will want to share their own WebAssemblies and basically leverage what we did already. So we created a list, of course, that's giving you all the list, and a publish, which basically pushing it to a hub. So basically it's just showing it in a hub and mean that other people can actually go and use it. So that's kind of like in the nutshell, but it's really like, if you think about it, it's Docker for WebAssembly and right?
So I haven't been tracking it for a bit, but I remember at KubeCon EU, there was specifically a talk talking about WebAssembly and Envoy. And at that point, things weren't primetime. It wasn't ready. It was still early beta. Is WebAssembly and Envoy fully supported and ready for primetime now?
So it's not upstream yet. This is what we're working on it as we speak. But there is a good branch, fork basically, and that's basically already exists there. And now we're just merging it back to upstream. It maybe will take a little bit more time, but not dramatically more time. There is stuff that does not exist. Like, for instance, you can do a lot of manipulation with headers, but the body is not something that you can do yet. There was bugs, so we fixed it. With the HTTP, how the registry actually can take it. But in the nutshell, it's starting to be very close to being time-prime. And also there is such a push from it, from the community and specifically from Google, that's what happen very soon. I mean, this is really a matter of, yeah.
I mean, I looked at the repo. There's something like 444 contributors to it. And it's pretty large.
Yes.
So what are some of the modules, some of the filters that are out there that are WebAssembly filters that you can plug in right now from WebAssembly Hub?
So what we did so far, and we open source, is transformation one. We did metrics, so, kind of like taking the metrics of Envoy and be able to publish it automatically. So it's exposing you metrics. We're going to push really, really soon one that related to AWS. So as I said, we have one in the open source filter for C++, no WebAssembly. In Gloo, that is, a lot of the users using it already. That, as I said, what's special about it is on the request, but it's basically taking the certificate and it's basically pushing it and creating an handshake with AWS and spinning up the Lambda for you. So we're doing that. Stuff that we are working on right now, again, we have it in C++, but we're moving it to WebAssembly. It's stuff like WAF, Web Application Firewall. It's stuff like data loss prevention. We have a lot of requests from customer for REST to SOAP transformation. So you will see that coming very, very soon. But basically, we're going to transform every of our services to WebAssembly, because right now what we're doing, we're taking our upstream Envoy and we're basically taking our custom filter and basically compile it and then pushing it. And that means that if there is like a security vulnerability or something, we need to do this process every time that there is. Versus if we will do it with WebAssembly, we will not need to do it. We will be able to go upstream and basically just extend it with WebAssembly. So that's where we're pushing it.
What was the tool that you used for WebAssembly Hub?
Yeah, we're calling WASMI.
Tell me about it. I'm assuming that's a Go tool that you all have written. Is that open source? Can I download and use it so I can pull it down and update my own Envoy?
No, so basically you download it as a CLI, right? It's a command line. You basically download it to your environment. You're doing WASMI init, and that basically set up all your environment and everything you need in order to build WebAssembly. And it's also, as I said, cloning a repository that we made to make it very simple for you to create that. And then basically you're just doing WASMI build, WASMI push, WASMI pull. It's like Docker command line, right? It's giving you the ability to do it with a powerful command line.
What about things like data types that are within like Rust or C++ and that translation that has to occur from WebAssembly over into like Envoy? There's certain things that are allowed. Does it handle all of that mapping and that translation?
Yeah, so right now, besides C++, which is what Envoy support, we actually extended that to support also Rust. I don't know if it's pushed or not, but I mean, we definitely had this code to support also Rust. Yeah, so we extended that. And basically, if you think about it, when you're building it, it's just a param. You basically said build, WASMI build minus C++ or minus Rust to build it in Rust. And then also when you're doing deploy, it's going to give you a parameter for what type of the VM. So it could be something like wasm minus sto minus now VM or whatever. That doesn't matter. Whatever VM you feel comfortable of doing it with. So it's basically giving you all those interfaces already built in.
Can you go back and forth between Envoy and WebAssembly? Do you have to stay all within like the WebAssembly runtime? What does that look like?
Yeah, so this is a work that's already been done by the community of Envoy. That's not something that we specifically done. But basically, you can imagine that it's basically a filter, right? So we have a channel filter in Envoy, and there is there will be a WebAssembly one. And then it know how to load your WebAssembly and basically do everything you need.
It's all filters?
Yeah.
It's all filters. So like intercepting filters or like exiting filters that allow you to be able to modify things that are coming in. What are the limitations of the things that you can do there? Or are there any?
So as I said, right now, it's just because they didn't manage to do that yet, but they will. There's a few problems. The first one is that the API could potentially change, right? There was API, which is fine, right? Eventually they're going to put it in the ABS. So, eventually they're going to be very solid. And the other thing is that, as I said, like for instance, right now, they only did a support for headers, but they didn't do for body. So that means that it's limiting us. For instance, if we want to do a transformation for the body as well, we cannot, right? So you don't have they're not exposing everything that Envoy can give you yet. But this is really, really important yet, because it's going to be changed. We're working on this right now. So eventually there shouldn't be any limitation.
So you'll be able to do everything that Lua can do today.
Exactly. And again, the point is that, of course, right? You can put as much as WebAssembly as you want as filters, but of course, like everything that you need to consider is a threshold of it's on the request path. So you don't want to do a very complex calculation on the request path because it's just going to slow dramatically the request. But that's all. Yeah. Besides that, it shouldn't be a problem. We're really excited about it. I think, once it will be Envoy and the way the plan is really, really clear, I think it will open so much. Even for me, right? We will be able to write tiny Go, right? Which means that I have, right now 5 engineers that are capable of writing and filters. Now it means that all my company will be able to write filters in Envoy.
So we've talked about kind of app gateways with Gloo. We talked about Service Mesh Hub. We talked about extending the mesh. What's next for you all? What's next for Solo?
So I think that Solo, what's special about it is that we're really ahead of the market, right? The only thing that we are not ahead is Gloo, and this is why, we did this. We decided to start with something that is not the head of the market. But if you think about it, people are just starting to get their head around service mesh and definitely about stuff like WebAssembly. So I feel that the only thing that we want to do right now is basically continue working with customer and make it production ready, full proof of all this stuff, and not actually do new stuff. Because I think we have other stuff that we're doing regarding to the, debuggable of the mesh, something that we like Gloo. We have chaos engineering. I don't know if you saw it. It's called Gloo Shot. But in the nutshells, we want to focus on the 3 pillars and just make it a really, really solid production product. Gloo is all ready. And we're working on right now with the customer for Service Mesh Hub and, as I said, everything else. But Gloo, as I said, is production ready right now. We just announced 1.0 is very solid. And now we want to focus about the other stuff that, we're already done, but we want to make it really, really solid.
Well, Idit, thank you for joining us on the InfoQ Podcast.
Thanks so much.